So, we are going to move to a much bigger world today for Algebra 2 level stuff. This is not something you would have seen in Algebra 1. Okay. We are going to solve a system of 3 variables. Alright. So, we're not going to just solve for 1, we're not going to just solve for 2, we're going to solve for 3 different variables in an equation, which means that we're going to have 3 equations. Alright, isn't that excellent? Here's the nice ones. This is technically what we call back substitution, because we're going to start from the back and work our way up. But I didn't give you any instructions on it because it's just as easy to just show you. Okay? So, we're going to take this 2. I'm going to take this 2 and I'm going to plug it in for z in that problem right there. Okay? And that'll let me solve for y. Then I'll be able to plug y and z into the first one. So, when I plug in, I'm going to plug in y plus 4 times 2 equals 7. What's 4 times 2?
8.
8 equals 7. And then what do I have to do with the 8 to solve for y? Good. And what do we get?
Negative 1 equals y.
Good. Let everybody make sure you have it written. Okay, now I'm going to take both the 2 and the negative 1 and sub it into this first equation here. So I've got x minus 2 times what?
Negative 1.
Negative 1 plus 3 times what?
2.
2 equals 9. Alright, what's negative 2 times negative 1?
2.
2. 3 times 2 is? 6 equals 9. What's 2 plus 6? 8. And then what do we need to do to move the 8? Subtract it, and what do we get? 1. Alright, so our final answer, think about this now. Okay? We got to write a coordinate of 3. You always do this in alphabetical order. So it goes x, y, z. So your x is 1, your y is negative 1, and your z is 2. So really what we've done is we've moved into the third dimension. Instead of it being on a coordinate plane, it's like on a, it looks like this. A plane that looks like that. So it's a dot out here in the place. So that's the regular coordinate plane, is the one that's kind of a piece of paper, and then this is like a line coming out of the piece of paper, and it's graphed like in space. Okay? Alright. Let's look at the next one here. So, I don't have it quite so easy where I can just plug in, right? That last one was really, really nice. This one isn't as nice. So what I'm going to do is I'm going to try to plug into, I'm going to try to solve for one of these. This one looks like it could pretty easily solve for something and use that to kind of eliminate things. Okay? So, I'm going to get y by itself in that one right there. So how do I move the z to the other side? Add it. So negative y equals z. And then how do I move the, well, does it really, I'm going to try to solve for y. So I'm going to move that negative over, so I've got y equals negative z. Okay? Alright. I am now going to take this, and I'm going to plug it into this function right here. Okay? So, I've got, I take that back. Y. I'm going to take it and plug it into this function here. Okay? So, because that will get me down to 2 variables and 2 variables. Okay? So, we've got x plus y minus 3 times, I want to plug in for z. I did it wrong. Yeah, I did it wrong. Let's just do this. Okay? Let's start that over. I'm going to solve this one for z. Okay, so we've got negative y equals z. Everybody cool with that?
Yeah.
I added the z over. I'm now going to take this and I'm going to plug it in for the z. Is that making sense now?
Yeah.
Alright, so we've got x plus y minus 3 times something equals negative 1. This is where I'm going to take and plug in the negative y for the z. Alright. From there, let's do some combining like terms. So I've got x plus y. What's negative 3 times negative y? Positive 3y equals negative 1. What's y plus 3y? 4y equals negative 1. Now I'm going to look at this equation and this equation and try to solve, just like we would do a system of 2 like we were doing last week. Okay? What should I use? Substitution, elimination, Kramer's rule. It's set up for elimination, isn't it? I've got a negative x and an x, so I'm going to come over here and I'm going to line it up underneath here. So x plus 4y equals negative 1. So I'm going to set that up as an elimination. What's wrong, Ivan?
Why didn't you take out the negative on the y?
Where?
On top, the first thing you wrote?
Here?
Yeah.
Because I wanted to solve for z. So I needed a positive z to plug in there.
Oh.
That's the mistake I made on the first time I tried it. Okay? I showed you the good wrong thing to do. Right?
You're wrong.
The good wrong thing, right? That's the first thing we would get wrong. Yeah. Alright, don't do that. Alright, so the x's are going to cancel. What's 2y plus y? 4y. 6y equals, what's 1 minus 1? 0. Thank goodness we don't want a fraction, right? Alright, I've got 0 divided by 6 is what? 0. Perfect. Alright, I've solved for y. Ooh, can I get z off of that? Look at that. Can I plug in there and get z?
Yeah.
So z equals negative 0, which is just 0. Alright, now I've got to solve for x. I could do the first equation. I can't do the second equation. There's no x's in it. Or I could do the third equation. So what do you want to plug into? The first one? Okay, I would have picked the third one, but that's fine. Alright, so we've got x plus, what's your y value? 0. Minus 3 times 0 equals negative 1. What's going to happen with both of those? They cancel, so we've got x equals... Okay, how would we write our coordinate now?
Negative 1, comma, 0, comma, 0.
Yep. There's your final answer. Alright, there are other methods other than what we call this back substitution. We can do elimination on this, because there aren't always going to be like this where it's kind of a nice thing to back substitute in. So go ahead and fill in the blanks, and we'll talk about it. Okay. So, to use the elimination method, you need to rewrite the system as a linear system in 2 variables. So we have to figure out how to eliminate a variable right away. Okay. Then you're going to solve the system of 2 equations for both the variables. And then you're going to substitute the 2 values you found in step 2 into one of the equations and solve for the last variable. Okay. This is not, it's not hard, it's just long. Okay, so we're at the point where we're not assigning a ton of homework problems, we're assigning a few so you get the practice for it. Okay, so I want to eliminate, I need to pick a variable to eliminate, and I want to eliminate this variable in all 3 equations. So I'm looking for something that has either matching coefficients with opposite signs or that I could easily get matching coefficients with opposite signs. So what do you think we should pick? I'd probably pick x. I'm going to and what I do is I call one of the equations the multiplier equation. So this one here I'm going to use as my multiplier equation. For the first set pair, I don't need to do anything, right? It's already opposite signs and the same coefficient. So all I'm going to do is rewrite them and subtract them. Or add them. Negative x plus 3y plus z equals negative 2. Alright, I know my x's go away. What's negative 2y and positive 3y?
Y.
Good. 3z plus z. 4z. Good. 9 minus 2. 7. Okay, so now I've got that down to a system of 2. Or two variables. This right here, I want to use as my multiplier. How do I get rid of the 2? What would I have to multiply this one by? 2, because the sign's already opposite. And I'm going to cheat a little bit. I'm going to write it right underneath this one. Okay? So negative 2x plus 6y plus 2z equals negative 4. All I did was I took and I multiplied my multiplier by 2. Make sure you multiply the negative 2, right? That's the mistake I said that a lot of people make when we did elimination the first time. Okay, 2's go away. That's what we planned. What's negative 5y and positive 6y? Good. 5z plus 2z. 7z equals what's 17 minus 4? 13, is that what I heard? All right, now I want you to look at what we have here. Look at the two equations that we have left. What do you notice? What can we do to these two equations right here? So this one and this one, I got to solve for y and z now. Am I going to use substitution, elimination, or Kramer's rule? Elimination. What variable is easy to eliminate? Y. Okay, so I'm going to multiply this one by negative 1. I'm going to write it underneath here. I try not to rewrite a ton, because the more I rewrite, the better chance I have of making a mistake, right? So minus 7z equals negative 13. Okay, the y's go away, that's why we planned it. 4z minus 7z is what?
Negative 2z.
Negative 3z?
Yeah.
Okay. 7 minus 13 is what? Good. What am I going to do to move the 3 to the other side? Good. So negative 6 divided by negative 3 is? 2. All right. Now I get to pick. I get to pick where I substitute. So I either can choose to substitute into the y plus 7 or the y plus 4. So what do you want to pick? Okay, so I'm going to substitute into this y plus 4 here. And I'm going to put the 2 in for the z. So we've got... my work's kind of all over the place. You can keep going down or to keep going to the right. That's fine. So y plus 4 times 2 equals 7. All right, what's 4 times 2? 8. And then subtract the 8. What do you get for the y? Good. Now we get to pick whether we go... Now we have to use one of the 3 original equations. So do you want to go into the first one, the second one, or the third one? Okay, so we're choosing to do the first one, and I'm going to substitute in both the y and the z that we found. So I've got x minus 2. What's my y value? Good. Plus 3 times 2 equals 9. 2 times negative 2 times negative 1 is? 2. 3 times 2 is?
6.
Good. What's 2 plus 6? 8 equals 9. X equals 1. All right. So, what is my coordinate?
1.
Perfect. And it happens to be the examples we picked that we're getting a lot of 1s, 2s, and 0s, okay? It isn't always going to be that way.
Is there ever to be a fraction?
There could be. I hope we didn't assign any that are like that, okay? All right, let's skip 4 and go to 5. How does that sound? Okay, because I don't want to torture us too much. I didn't do the work on 4, so I did the work on 5, so I kind of know what that's supposed to be. And then I do want to do 6. We are not going to do the Kramer's rule ones. I can kind of give you an idea of what it looks like, but it's kind of a mess to do Kramer's rule with this, so I don't show it. If you really want to learn it, I can find you a YouTube video, okay? I'm sure. All right, so looking at this one, oh, look at how nice this one is. Look, examine that carefully. What would we use to, what would we eliminate first? What variable?
Z. Y.
Why the y?
Because you already have.
Yeah, look at this middle one. Wouldn't it cancel both the top equation and the bottom equation?
Yeah.
So I don't need to do any multiplying. All right, so here's what I wanted you to do. We're agreed we're going to start by eliminating y, right? So that's our agreement, is we're going to eliminate y. So I'm going to add together the x plus y minus z equals 13. Did you guys notice I put the slash through my z?
Equals 3.
Equals 3, thank you. It's good when So I put the slash through my z so it doesn't look like a 2. All right, minus y minus z equals 1. Okay, so you're going to add that up, and then you're going to add these bottom two. Do I even really need to rewrite the bottom two?
No.
Okay, so I'm going to give you a minute. I want you to see how far you can get with just example 5. Try to add them up, and then try to solve the system of 2. Okay? So everybody take a good minute on your own, see if you can get it done. All right, let's take a look at it. So what's x plus 2x?
3x.
The y's go away. What's negative z and negative z?
Negative 2z.
Equals?
4.
Perfect. All right, I'm adding these last two together. So what's 2x plus x?
3x.
The y's go away. That's what we planned. Negative z and negative 2z is?
Negative 3z.
Equals?
6.
Good. Substitution, elimination, Kramer's rule.
Elimination.
Elimination, what did we eliminate?
I don't know you want 25.
The 3x, it's set up for it, right? How beautiful is that? So, I'm going to choose to eliminate this one. You could have gone the other way. You're going to get the same answer in the end. Okay, so I'm going to distribute a negative there. So negative 3x plus 3z equals negative 6. All right, the 3x's are gone. That's negative z and positive 3z.
Z.
4 and negative 6.
Negative 2.
All right. So now I've got to plug in. Do you want to go into the one with the 3x and the negative 3z, or the 3x and the negative 2z?
Negative 2z.
Okay, so I'm going to come here. Let me switch colors so I can kind of keep following the work better. I'm going to come into that one right there. So I've got 3x minus 2. What's going in for the z?
Negative 2.
Good. So 3x, negative 2 times negative 2 is what?
Positive 4.
What am I going to do to move the 4?
Subtract.
Good, what do you get?
0.
And then divide by 3 we get?
0.
Awesome. So we've got a negative 2 and a 0. From here, you could have all picked a different one, and that's okay. Do we want to go into the first, the second, or the third?
First.
Okay, first one. So what am I putting in for the x?
0.
The y is what we're solving for. What are we putting in for the z?
Negative 2.
So notice it went double negative because there was a negative in the problem. Equals 3. Double negative goes?
Positive.
Do I need to worry about that 0?
No.
No. So how do I move that 2 to the other side?
Subtract.
What do we get?
Y equals
1. How do you write your final answer?
0, negative 1, negative
0, 1,
2.
negative 2. And again, we got 0s, 1s, and 2s. Again, it won't always be that way. Okay, in fact, the next one's not going to be that way. All right. So, this next one, I'm going to tell you up front, it's a special case. Okay? And I want you to be aware that there are a couple of special cases out there. Because what happens if we don't have an answer, right? We could end up with no, or we have an infinite. Remember we had a no solution and an infinite solutions when we did a system of 2? Well, we can have that with these as well. Okay? So, let's go ahead and pick a multiplier. This is how I start these. So, what do we want to eliminate? The x's, the y's, or the z's? Okay, I heard x's. I probably either want to pick the first one or the third one as my multiplier. I'm going to go with the third one. Okay? So I'm going to rewrite the first one exactly the way it looks. So x minus 3y plus z equals 1. What do I have to multiply this one by?
Negative.
Just a negative 1. Okay, so I'm going to distribute that negative through. Minus 2y plus 3z equals 1. What's going to happen with the x's?
Cross out.
They cross out. What's negative 3y and negative 2y?
-5.
And then z plus 3z is
4z.
equals 2. All right, I'm going to take this one here, and I'm going to rewrite it, because I'm going to have to multiply the second one there. So this time I do need to rewrite. Can't get away with not rewriting. Okay, what am I going to have to multiply this one by to eliminate the x?
-2x.
Negative 2. Okay, so I've got negative 2x. What's negative 2 times 2y?
Negative, right?
Good. Negative 2 times negative 3z.
Negative 6z.
6z. Negative 2 times negative 1 is?
2.
2. All right, so the 2x's go away. What's negative y and negative 4y?
-5y.
Negative 5y. Negative 2z and 6z.
4z.
4z equals what? 4. Ooh, look at. Pretty nice. We've got coefficients that are the same. I just need to do a multiplier, right? Need to multiply. So I'm going to multiply this by -1. And I'm going to write it underneath here. So I have 5y minus 4z equals -4. What's negative 5y and 5y?
0.
What's 4z and negative 4z? 2 and negative 4. Do you see how we got a false statement?
Yeah.
This is a false statement. When it's a false statement, there is no solution. This is something that would be good to add into the left-hand column, right? False statement is no solution. What would happen, though, you think, if I got a 0 equals 0? Or a number equals itself? There was another scenario, wasn't there? We had no solution. What was the other one? Infinite. So if you get something that it's a number equals itself, typically it's 0 equals 0. That's where we get infinite solutions. I'm not going to show you one because I know these are long and I'd rather you just get started on the assignment. But if you run into that in the homework, that's what it is. Okay? Are we likely to give you a no solution or infinite on a test? Probably not. Maybe in a 2x2, right? But not necessarily in a 3x3. Okay? So there are a couple left there called Kramer's rule, right? Remember when we did the 3x3 determinant? We had the 3 numbers in the column. The Kramer's rule works identical to that. I'm not going to do it because guess what? I would have to do 4 3x3 determinants to solve that. That doesn't sound like fun to me. I personally think on these, elimination works better. There used to be a time in my career I would only show them Kramer's rule on that. But I've decided, I've gone back to, I like doing this better, and I usually we do better on this than the Kramer's rule and the 3x3. Okay? If you want to learn the 3x3, great. Okay? If you really are excited about Kramer's rule, I can show you how to do it. Okay? Alright, if you look in haiku, you might need to refresh from the beginning of the period, because I put it up after you guys walked in the door. Oh, I don't have it up yet. I'm not giving you